All right, this video is to demonstrate how to build a nonlinear regression model in the TI-84 Plus calculator. So the steps we use in class are to analyze the data for the overall trend, create a scatter plot of the data, determine the type of model, quadratic, exponential, logarithmic, sinusoidal, that possibly best represents the data, and then perform the appropriate nonlinear regression to generate a model. So in class, we used an example of Super Bowl costs for 30-second ads. And that's what I'm going to go through today, just to show you again how to create that nonlinear regression model for that data. So the first thing you're going to want to do is we need to get the data into the calculator. So again, we're using this data from this article. It's linked in the presentation for this lesson. And so where you want to go in your calculators, when you have your calculator turned on, you want to press the Stat key, and this first submenu, Edit, is all about the list editor. And so we're going to edit the list. In an L1, we're going to type in the years for all the years presented in the article. Starts at 1967, goes to 1970, then it does every 5 years up until 2015, and then it goes every year until 2023. And then L2, we're putting in the cost for a 30-second ad during the Super Bowl in thousands of dollars. So in 1967, it cost $42,500. So I've put in 42.5. Once we get to 1995, it rolls over to over $1 million. And so then, because this is in thousands of dollars, in other words, I'd need to put 3 zeros behind it, I enter 1.15 million as 1,150. And we just carry that adjustment through the rest of L2. So that gets the data into the calculator. Now in class, when we did this example, we looked at the data and we determined that it was increasing, but it was not increasing at a constant rate. And so then we determined that it was increasing at an increasing rate, which led us to believe it was exponential. So step 2 is we want to create the scatter plot of the data. So we've given it the data, now we want to create a scatter plot. So to create a scatter plot, what I'm going to do is I'm going to press second and y equals to get into the stat plot menu. If the calculator's been reset, all of these will be off and they'll all be set back to the default of a scatter plot, L1, L2. So I'm going to pick one of my plots. It's defaulted to off because off is highlighted. I'm going to press enter to turn it on. The type of plot that I want is this first one, that is a scatter plot. And then I'm going to tell it what data I want it to use for my X list. In this case, I want to use the years, which we did put into L1. And the Y list, I want it to be the cost for those 30-second ads, which we put into L2. The mark is up to you. I tend to stay away from the small dot on the right because it can begin to be hard to see where your data points are. And then the color is completely up to you. Once I have all of this selected, then what I'll do is I'll press zoom, and I want to select number 9 down here, zoom stat. So I'm going to select number 9, and here's our scatter plot. And so this backs up, or at least it looks like it backs up, our guess that the data here was going to be exponential. I see what looks like an exponential curve. So then step 3, determine the type of model. I think exponential is a good one to build, but we could try, for instance, a quadratic model. Perform the appropriate nonlinear regression to generate a model. All right, so we think it's exponential. We've looked at a scatter plot of the data. We still think it's exponential. So the next step then is to build that model. To do that, what we're going to do is we're going to press stat again. But now we're not worried about editing the lists. So we're going to come here to calculate. And then I have some other statistical stuff here, but starting with number 4, I have all of my regression algorithms. So I'm going to scroll down until I see one that looks like exponential regression. Here it is. It's option 0. So I'm going to select that. Notice here at the top it tells me what type of regression I've selected. It wants to know what I want to use as my X list, in this case the years, which we put in L1. It wants to know what I want to use as a Y list, which is the cost for a 30-second ad in thousands of dollars. I put that into L2. Frequency list we're not going to use because this is in case we're dealing with a data set where a single value is repeated multiple times. I can tell it to use, instead of typing them, you say if the value of 2 was used 17 times, instead of typing in 17 2s, I can create a third list and say, just use this value 17 times. So we're going to leave that blank because most of these costs were unique. However, I do want it to store the regression equation so that it will graph it over the top of my scatter plot. To do that, I'm going to press vars, and I want to use y variables. So I'm going to go to the right. I am going to use it as a function, and then I can select any one that I want. Now, if there's something in a particular y variable that you want to keep, note selecting it here will completely override it. The calculator's not going to warn you that you're going to overwrite something, so make sure you're keeping anything that you want. In this case, we haven't done anything yet, so I'm going to use y1, and I'm going to press enter. So again, the calculator tells you, you just ran exponential regression. Here's the form of the model that I'm using, y equals a times b raised to the x, and here are the parameters for that model. Now, for A, we have 1.61 approximately e negative 71. Remember, this means I need to move the decimal 71 places to the left. So I need to take this decimal here behind the 1 in A and move it 71 places to the left, which makes this number extremely, extremely small. It's not 0, but it's extremely small. And then B, of course, is 1.09 if we were to round. And so that would make our model. So coming back over here, if I want to record my model, I would just come in here and say, well, it's approximately y equals, and I have 1.61, and I could do the, let's see, times, and then we'll do 10 raised to the negative 71 power. So that e that we saw is really the same thing as using scientific notation. There we go. And then we've got to multiply this by our base of our exponential, and that was where I estimated about 1.09 if we round, and this will be raised to the x power. And so that's our model. That's the exponential model we just had the calculator create using nonlinear regression. Now, the next part of this is I want to see, does that model fit the data pretty well? All right. Now, there's going to be another lesson on model of best fit and how to determine if it's a good fit for the data. But that's, again, for another lesson. So we're going to come back here. I've already got my scatter plot set up. So now I'm just going to press graph again. It's already sized to the window to see the scatter plot. And all it's going to do, because I stored that equation in y1, you can even look to make sure it's stored. Sure enough, it is. When I press graph, it's not only going to show my scatter plot, but it's going to draw this model on top of it. And so here we are. Doesn't look too bad. It goes through the majority of the points. But like most data in real life, it's not perfect. We have a few points above, several below. Doesn't look too bad. And so I would be happy for right now with this model we generated. And I could go ahead and use it to answer questions. Now, again, there's going to be another lesson showing us how to determine if it's the best fit. But that's it for today's video on how to create a nonlinear regression model using the TI-84 Plus.